Here I'm going to show how to write a compound inequality when you're given a graph, and specifically a graph on the number line. I have two examples, and my first one is right here. I notice that I'm on the number line. I have my solution set is graphed. I have two endpoints, and those are going to be some big focus points for me. I'm going to focus right here at this one, which I notice is at -2. And then I notice that my solutions go to the right. So I could kind of think of this as my graph just looking like this. And what would I do to write an inequality that would represent that one? So I'll start with that one. Now I notice here it starts at -2, it's filled in, so it tells me that I'm going to have to include -2. And then it goes to the right, so I have all these numbers that are greater than -2. Think about writing that. I pick my variable, which in most cases would be x, and I would write x is greater than, and since it's -2 is included, equal to -2. But then I have that other part here at 5. And again, this one is filled in, but then I notice my graph goes to the left. All the solutions are to the left. So I can kind of think of it, it goes like this. And when I look at the blue one, that one, again, my x would be x, and then now all my numbers are less than or equal to 5. But since it's just the numbers in between -2 and 5, I think to myself, well, I have two inequalities that have to have both of them being satisfied. That's why I only have the numbers in between -2 and -5 shaded in. And when I had to satisfy both of them, I remember that that was an and inequality. So I really have to have this inequality that says this one. So if I clone that one, bring it here. And then I have to have that other one that says, oh, hold on here, and the other one, which is up here. Clone this one and bring this one down. There's my compound inequality with and in it. Now, most of the time we don't like to see it this way. We like to shorten it up a little bit. So this is where we have to do a little work. Now, remember a compound inequality with the word and, we put our variable in the center. And since I used x, it'll be here. Now I have to write both of these inequalities. I'm going to start with my red one. As I read it forward, it says x is greater than or equal to -2. Now notice I already have my x there. The -2 is going to have to come out here, and then my sign is going to become a less than or equal to. Because if I read this going forward, it says x is less than or equal to, or excuse me, -2 is less than or equal to x. If I read it backwards, x is greater than or equal to -2. And that's the same thing that it says right there. Now in my other one, the blue one, it says x is less than or equal to 5. Well, I already have the x right here. I just need the less than or equal to 5. So then I just have to put less than or equal to 5. And I have written my compound inequality for the graph above. Now my second one, my graph looks a lot different. Instead of my solutions being inside of those two endpoints, now those solutions go left and they go right. So I look at the blue one here. Notice that this is at -4. Well, I'm including -4, so I'm going to have the equals to part. And then I have all these solutions that are to the left or less than. So I would have x is less than or equal to -4. And then I go to my red one. Well, I notice that this endpoint's at -1, but I'm not going to include that one because it's an open dot. And then I have all the solutions going to the right or greater than. So I have x is greater than -1. Now, is it possible to satisfy both of those inequalities? No. And then this would be an example, because of that, this would be an example of an or inequality. So I have x is less than or equal to -4, or x is greater than -1. And we've written a compound inequality to represent that graph. And then that will conclude my lesson on writing compound inequalities from a graph.